Hello. So I will talk about what we do with machine learning in Rakuten and what we use it for. But first, maybe I should explain a bit about Rakuten. Maybe some of you don't know about it. So Rakuten is one of the, maybe the biggest e-commerce website in Japan. But in addition to e-commerce, we provide a lot of other services like travel or digital content. Maybe you know about Kobo or Viber. And probably you know about Prime Minister in France, which is also part of Rakuten. And Rakuten has a dedicated department for research with about 120 people worldwide. And what we do is try to leverage the state of the art in machine learning for improving the business and the user experience. So we do a lot of machine learning, including deep learning, natural language processing, computer vision. And we also work on the user experience, experimenting with immersive technologies. Maybe I will go back because maybe you noticed I've written 1.2 billion users. So it's really huge. A big part of these users come from Viber. But with so many users, we have a lot of data. The data comes from the tracking we do with, from user behavior, the messages and reviews sent by the users. And a lot of data comes from the text and images associated with the products of our the catalog of things that are sold online. And many teams are using this data their own way, like marketing team, customer service, fraud detection teams. And they have their experience in dealing with the different types of data. And during several years, they put some different procedure and automation processes in place. But in the beginning, like 10 years ago, usually everything was done manually. And at some point, they figure out that there are tasks that they repeat a lot, and they create simple procedure to automate the process. But eventually, they get stuck because these rules, they have to come up with them intuitively or based on their experience. And it's difficult to scale them, and it's difficult to update them. So that's when machine learning is useful. So for instance, for customer service, people used to answer each individual request from users, like by email or through their information system. Or for a product, the catalog of products, they used to check every attribute or category of products, not of all the products, because there are millions of them, but for the most important one, they do that. For fraud detection, they put in place some rules based on the experience of what fraud was on the website, and so on. For catalog team, for instance, they created a bunch of regular expressions to extract from the text associated with products, the categories or the attributes. So that's quite powerful compared with the manual process, but when you have dozens of regular expressions, it's very difficult to maintain and update, and it's not at all machine learning, and machine learning is much more powerful. But so when Rakuten Institute of Technology arrives and suggests some improvement to the teams, we don't tell them, okay, now we will do a serious business and please leave the floor and we will start everything from scratch. We don't do that. First, because it's not very nice, and also because that's not the way it works. Because the huge experience the different business teams have, or technical teams, is really crucial for starting any project with machine learning. So these are projects. We start with them, and we gather data with them. We try to understand what they do. We cannot use machine learning without doing that. During these different stages of improvement, we reach different orders of magnitude in the automation. So when we have rules, we process a bunch of items at the same time in batch, but when we have machine learning, it really scales up, and we can update by doing trainings. So now I will explain a bit about one approach we use for many projects, not for all of them, but mostly when we use deep learning, which is transforming things into vectors. So if I take the example of the pictures and text associated with the products, if you take the raw data, you have, for instance, the pixel, like 1 million pixels for a picture, and that's a vector in millions of dimensions. It's a big space. And for text, it is the same, because one way of representing a text is having like one dimension per word, for instance. So from a huge dimensional space, thanks to deep learning, we transform the vectors representing the different objects, like products, into vectors in a much meaningful space where the distances between objects are semantic distances. So for instance, if we start from furniture products, we will have all the chairs in the same area and the tables in another area nearby, and product from other categories like fashion will be further, and so on. This is extremely powerful. See, this is what we call embeddings. It's not at all something we invented. It's very broadly used, but this is a very powerful approach. And for instance, it can be used to search for similar products, especially for fashion. It's difficult to describe a product with all these attributes, the colors or the patterns on a shirt, for instance, or the cut, the shape. But with this representation, we can look nearby, and the nearest neighbors or approximate nearest neighbors will be similar items. Another thing we do with a fashion picture is to extract the areas where we recognize the product and link this part to the place where the products are sold. And of course, with having this representation with semantic distances, we can do search based on images where we retrieve the products that are visually similar. And this works incredibly well for fashion and for furniture, for instance. For other categories, it's not so well. Regarding the catalog of products, there is a huge work to do for cleaning and having a well-structured database of products. And this is crucial for SEO, search engine optimization, or the user experience when users browse categories. So for instance, we discover that two products are in reality the same because of these semantic distances, so we can merge them. Also, we normalize attributes. For instance, people like to spell book author names in various funny ways, but we don't like that, and we try to have a normalized way of spelling them. And a very broad topic is about extracting categories and property or attribute values of the products from images and text. For a marketing team, what we broadly do is scoring. So we score products, and we score users, and we can score merchants. And what is the purpose of that is, for instance, that if we score products based on their profitability, we can decide what product to promote, like through Google Shopping, for instance. And regarding customers, if we evaluate the probability that a user becomes a Rakuten Club members, which is our loyalty program, we can do much smarter marketing campaigns. For customer service, obviously the data are mostly text. An interesting technology we use is topic modeling. And it's a totally unsupervised training we use, which extract outstanding topics. We don't provide any information for the training. As I said, it's unsupervised, but the topics appear, and associated with them, we have a list of keywords that helps us figure out what the topic is about. So it's very important for evaluating the different worries the customers have and what they report to the customer service, but also beyond the customer service to detect some issues with the website, for instance, or something that doesn't work. And along with this topic modeling, extraction of topics, we do some sentiment and emotion analysis. So we can associate with the topic some emotion, like people are really angry about this topic or very happy. And finally, we try to predict which type of answer is appropriate for a particular request, like a template for answers. So all these things help automate and improve the processing of the request from customers. And as I said, Viber is also a subsidiary of Rakuten. It's a communication tool. And we have to do spam detection with this service. But the problem is that the content of the messages are encrypted end-to-end. We were not able to use the content of messages to decide whether they're spam or not. So we have to gather various features, like the fact that some users or messages have been reported as spammer or spam, that the sender is in the contact list, the times when the messages are sent, and so on. And another approach we do is anomaly detection, like detecting when a special behavior is a bit weird compared to the normal use of the tool. So this was my last example, and as a conclusion, I want to remind these different stages I explained about, from a historical way of dealing with different business processes to rules that are manually configured, and finally to machine learning. So it's really a kind of continuous process, and machine learning arrives quite naturally in the end. Thank you.